This video will cover the zeros of polynomials, second part. And so I believe last class we left up here, where we looked at the definition of a polynomial, which is that, where it says that all exponents need to be integers. And so from here, we could say that a letter is a zero. I'm sorry, a numerical value will be a zero if we're talking about the function. We call it 0. And those are the x values for which the y is equal to 0. So that's what we're referring to. Now, if we call them roots or solutions, then we are referring to the equation. Now, when those zeros are real, we could see them as x-intercepts if they are real numbers. Okay, now let's say that we have a 0 that says x is equal to c, just to use a number, okay, c for constant. So if I was to take that number as positive c, right, if I take it back to the left side, it will be x minus c. And what is the right side equal to? 0. So we actually could refer to that expression as a factor. So it is very important that you guys know how to go from a 0 to a factor, and of course, vice versa, from a factor to a 0. All right? The TSI is like full of those questions. We also know that if that number is a real number, then it will look as an x-intercept, like what we said before, right? Those zeros. All right, and of course we have our example here, and we have here the zeros will be at -3, at -2, at +1, and +2. There are, so we could say the zeros are x equals 1, x equals 2, x equals -2, and x equals -3. So from there, those are the zeros. I could say that the factors will be x minus 1, x minus 2, x plus 2, and x plus 3. So if you notice, all I did was to take those numbers across the equal sign so that they would be with the x. So same thing that you guys have explained here. Here are the factors, here are the roots, here are the zeros. All right? And of course, the x-intercepts. Now let's move on to the next slide, and we're going to look at a new concept. And actually, I'm not sure if we got to look into this one, but the fundamental theorem of algebra, it says that every polynomial must have at least one root. If it is a degree greater than 0, which that will start with linear functions, they are of degree 1, right? So even linear functions will go in there, and they will have at least one complex root. And it doesn't matter if they are imaginary, because we establish how complex is divided into real and imaginary. So what this tells me, the fundamental theorem of algebra, is that every polynomial will have at least one root, whether it's real or imaginary. Okay? All right, now let's move on to the new stuff. Now, we have here something that is called the corollary of the fundamental theorem of algebra. You guys know what that word means? Corollary. A what? Correlation, back, kind of like that, yeah? Now, it's kind of related to the theorem, yes. And so it's like a variation of the main theorem. So the main theorem says that every polynomial will have at least one complex root, right? So the corollary says that any polynomial equation of degree n has exactly n roots in the set of complex number, including repeated roots. So what this means, that if you have degree 3, you will have 3 roots. If you have a degree 4, you will have 4 roots. Degree 5, you will have 5 roots. And so what is the difference between this and the previous one? That here we're already talking about repetition, when the roots repeat. We're going to get to see those examples later on. Uh-huh.
Aren't there like some quadratic functions that will happen to?
Yes. So what we will say is that, for example, let's think of this one. Let's make this a 3. So in this case, the only 0 that we could see is x equals 3, right? Yeah. But the factor that comes from there is actually what? What would it be, Marco? X plus 3 or x minus 3? Minus 3. That's the factor, right? But the equation for that graph that I gave you guys is actually this. So because this factor is occurring twice, the 0 occurs twice. And so when that happens, why? Because the factor has the exponent of a 2. So when that happens, we say that the 0 is of even multiplicity. And what that means is that the graph will touch and turn around. Do you guys remember that song? Turn around. There you go. You should play it. So that happens with all zeros of even multiplicity. So even though we only have one distinct 0, we still have it twice, which matches the degree of the equation. Okay? So what that means, like when we say including repeated roots, is like it doesn't matter if the 0 repeats, we will still count it. Like if we have a 0 that repeats 3 times, you will still count it 1, 2, and 3. Okay? Okay. Good question, Marco. All right. Now, new concept. Descartes' rule of signs. It is worded a little bit weird, but it's not very hard to use. Okay? And so what we're going to do here is this theorem is only good for 2 things. Well, actually 1. To tell you the possible negative or positive number of real zeros. But I want to make emphasis on this. Possible and number of. It's not going to tell you how many zeros you're going to have, and it's not going to tell you what the zeros are. It could just tell you how many positives. It could be like, oh, well, you could have 4 positives, or 2, or no positives. You could have 1 negative, or 3 negatives, or 5 negatives. Okay? Now let me show you how we will use it. So this theorem was actually, or rule of signs, was created back in the day when, I mean, I don't want to lie to you and give you the wrong year, but I'm talking about like 1800s, probably 1700s. We'll look it up during the break. And so it was created when calculators didn't exist. So it is very, sometimes you kind of like, what is that good for? But I can tell you one thing. I have used it before. And you could have a question like that on TSI. And it's very simple to use. All right? So let's use it. I know you're all waiting. So we're going to count how many times the sign, like plus or minus, how many times it changed. That's what we're going to count. So for p of x, like the regular polynomial, that would tell us the number of possible real zeros by counting the sign changes on the original polynomial. What about negatives? Well, so for negatives, we're going to have to do a little bit of work. First of all, we're going to have to find p of negative x. And then we do the same thing. We count the number of changes in sign. So let's look at an example. Okay. So I know that we already solved this problem, but I'm going to use it. So if you want to write it on some scratch paper, I'm going to use that problem number 3 to demonstrate the example, okay? So just write it on your notes somewhere. Okay, so let's see. We go from here to here. How many sign changes do we have there? Did it change? It did, right? It went from positive to negative. So that's 1. And then negative to positive, 2. And then positive to negative, 3. And then negative to positive, 4. And positive to negative, 5. Okay, so because of that, the possible positive number of real zeros is going to be 5, or, now here's where the tricky part is, okay? We're going to subtract 2. So 5 minus 2 is 3. Or, what is 3 minus 2? 1. And we stop there. Why do we stop here?
Because you can have 0 zeros.
Well, actually, you could have 0, but what would happen if I do 1, if I subtract?
You get a negative.
I'll get a negative 1, right? And we cannot have negative possibilities. Okay, so we will just say either 5, 3, or 1. Now, let's look at negatives, okay? Now, to get the possible negative number of real zeros, first we need to find what will happen if we turn every x to negative x. So please write down this on your paper. I believe these are actually questions on your homework, right? I'm just going to write this here on the list. All right, now you should know that anytime you have an odd number for the exponent, the answer from here is going to be positive or negative? Negative, okay? So let me show you why. Because you're multiplying negative x times negative x times negative x times negative x times negative x, right? By itself, by times. So from here and here, you get a positive sign, correct? Negative and negative. From here to here, you get positive. And then what do you get positive times positive?
Positive.
Positive. And then what do you get positive times negative?
Negative.
You get negative. So that's how I get this negative x to the 5th. Now when I look at the next one, it will be negative x to the 4th power. So that is negative x times negative x times negative x times negative x. And so this is an even power. So here and here is positive, here and here is positive, and positive times positive is positive. So this is going to be positive x to the 4th. However, I still have this negative that was part of here. Okay, now the next one, since we have a 3 for the exponent, and we're raising negative 3 to the, negative x to the 3rd power, so will that be positive or negative?
Negative.
So that will be negative x cubed. The next one is negative 45, and here I have negative x squared. This is an even power, so that will be negative x times negative x is positive x squared. And then finally here we have positive 14 times negative x, so that will be negative 14x. Okay, now let's continue to clean this up a little bit more. So negative x to the 5th, negative 5x to the 4th, negative 9x cubed, and then negative 45x squared, negative 14x, and then negative 7. Okay, now I want you guys to please take a look at it and tell me if there's any question that you have, any type of problem, or if I made a mistake, let me know now. Yes?
I was going to ask about positive.
Which one?
Like, how you can get
With 3? And 1. Okay. So the rule I was kind of waiting on that. But the rule states that you count the number of sign changes and then, or, is less than this by an even number. So that's why I told you guys we're going to keep subtracting 2. Okay? So 5 minus 2 was 3, and then 3 minus 2 is 1. Now, one way the pre-calc book tells you is this. The number of sign changes, minus 2k, where k is an integer. So it will be kind of like, if k is 1, you subtract 2. If k is 2, you subtract 4. If k is 3, you subtract 6. In other words, you just keep subtracting 2. Minus 2, minus 2. If you get the same result. Now let's count the sign change. Are there any problems, guys, with how I handle my algebra here? Any question that you might have before I move on? If there's something that you're not so sure, why do I have positive? Why do I have negative? Ask me. Other classes have asked me for every single term. Seriously. So don't be shy.
So you just change the signs for the equation.
So what I did is just substitute the negative x for every single x that we had. And this is because we are after the possibilities of negative real zeros. Okay, now once I do that, yes, Marco?
I was going to ask you for the amount of possible negative zeros.
Say that again?
I was going to ask you what the amount of possible negative zeros.
Oh, well, let's get to that. So let's see, how many sign changes do you guys see?
No.
Negative, 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 negative. So no sign changes, right? So the answer is? Or none. Or NA. Hold on, Maya. I want to be in the picture. Do you guys remember what were the zeros? You should have them. X equals, what were they? What was the real one? That was a real one.
5.
5?
Yeah, 5.
And the imaginary?
The square root of 2.
And then, if I have that one, I should have the complex conjugate, right? Negative. And then, if it's degree 5, how many zeros do I need total?
5.
5.
And then there's another one is negative and positive imaginary set.
Square root of 7. So we have 5 in total. Now let's see if the card rule of signs makes sense. So it says how many positive can we have? 5 or 3 or 1. But only real. How many positive real zeros do we have?
1.
Only 1. It's right here. What does the rule of sign tell me about negatives? That we have how many?
None.
None. And this is only real, okay? This is only real. So none at all. Okay. Let's say we were going to count the sign changes here. How many sign changes do we have?
None.
None. So that means that how many positive real zeros could we have?
None.
None. The only real zero we had was negative, right? On that problem, you should have the answers on your paper.
I gotta find how to
Not for this one.
What?
For number 4.
It's negative.
It's negative 5.
It's there.
It's negative, and the other 4 are imaginary. Okay. So that is the card rule of signs, guys, for you. You just count the sign changes. All right. On your homework, you do have questions like that, right? Like how many positives or how many negatives could you have, I think. Yes, Metroville? I think so. All right. Complex conjugate theorem, I think I already touched base on this one, but let's talk about it quickly. If you have a zero that is imaginary, then you know for sure that you will have the complex conjugate of it. So that's why every time we get a zero like 2i, we will have negative 2i. If we had a zero such as, let's say, 3 minus 5i, what will be the other zero? 3 plus 5i. So those are examples of complex conjugates. All right, next slide. And the last one, I think. Rational zero theorem. So we're going to be using this one today. And let's see what we have. So if we're talking about rational zeros, we're talking about rational numbers, all right? And remember how rational numbers is the ratio, that's why we call it rational, ratio of an integer divided by another integer. Just like that. So you guys notice right here, the fraction, the ratio, p over q. So those are going to be the form of our rational zeros. Now let's see where that p and the q represent, okay? So the lowercase p is representing the factor, I hope you have your highlighters, the factor of the constant term. That's what it is. And Q is the factor of the leading coefficient. I have more highlighters. Who needs a highlighter? Oh, you want a different one? Yeah. You need one, Alexis? Yes. Okay. Okay. Anyone else who needs a highlighter? Okay. Oh, you're gonna get a purple one. And make sure I get it back because this is my favorite, okay? I love purple. All right. Now let's see what this theorem is about. So what we do is we look at the constant term, which is, in this case, for our example, is negative 40. And then, of course, we have to look at our leading coefficient, which is 6. So we're going to take the factors of the constant term, which is negative 40. What are those factors, guys? 1, 2,
3,
no, 4, 5, 8. What do you say?
10. Oh,
No, you said something about negative?
I converted a negative 4 in the there. 10.
What else? 20?
40.
Yeah. Okay, so we have 8 in total, right? I'm going to tell you one thing. We're missing another 8.
Negative 1.
Mm-hmm.
Negative 2. Negative 1. Yeah.
Plus minus, because that means negative 1, positive 1, negative 2, positive 2, negative 4, positive 4. So let's do that. So now how many do we have total? 16. Okay, so we take that, and then we're going to divide them by the factors of the leading coefficient. What's the leading coefficient, guys? 6 1, plus minus 2, plus minus 3, and plus minus 6. Okay. Now here comes the fun part. So now to get the possible rational zeros. So in this case, we're excluding everything that is imaginary, of course, because that's not real. And to be rational, first you have to be real. So we're excluding all imaginary, but we're also excluding all irrational, all the ones with the square roots, with the radicals. So in this case, we will take all of the numbers that you see here, all of them, and then divide them by 1. So we're going to get the same numbers, right? Come on, write them down. Write them down. Okay. And now what we're going to do is we're going to take all those numbers in the numerator and we're going to divide them by 2. Okay, so are you guys ready? Pay attention to the board and then I'll give you like 10 seconds to copy it. So let's see. 1 divided by 2, so that will be what? 1/2. 2 divided by 2 is 1. We already have it, so we don't need to repeat it. 4 divided by 2 is 2. We already have it. 5 divided by 2, we don't have that one. 5/2. So let's just keep them in fractions because we want rational numbers, right? And so we wanted to look at the ratio of 2 integers. 8 divided by 2 is 4. We already have it. 10 divided by 2 is 5. We have it. 20 divided by 2, we have it. 40 divided by 2, 20, we have it. Okay, now we move on. We already divided by 1 and 2. Now we're going to divide by 3. 1 divided by 3 will be 1/3. 2 divided by 3, so 2/3. And then 4 divided by 3, 4/3. 5 divided by 3. And then 8 divided by 3. 10 divided by 3. 20. 40. Okay. I'm sorry?
Where are these fractions coming from again?
Well, we're taking all the factors of 40, which are the numbers that I have circled with green, with the green highlighter in the numerator. And then we have to divide them by every number here. So divide by 1, we did that. Divide by 2, we did that. And then divide by 3, we did that. And now we're going to divide by 6. So you guys ready? Okay, so 1 divided by 6, 1/6. 2 divided by 6, 2/6. But that one reduces to 1/3. And I already have 1/3. Okay. 4 divided by 6 reduces to what? 2/3. We already have it. Okay. 5 divided by 6, we don't have that one. 8 divided by 6 reduces to what? 4/3. And we already have it here. What else? 10? 10 divided by 6? That would be what, guys? 5/3. Do we have it?
Yes.
Yes. And then 20 divided by 6, that is what? 10/3. We have it. And then finally we have 40 divided by 6, and that will be 20/3. So that's it. That's all we have. So how many possibilities? Remember, these are only possibilities. Again, this theorem was created when calculators did not exist. All right, now quickly, this is the very last thing on your notes, and that will be the corollary. Remember, like variation or a correlation to the original theorem. And so that one tells me this. If the leading coefficient is equal to 1, then the possibilities are just going to come from the factors of the constant term. So imagine that we didn't have the 2, the 3, and the 6 to here. Like if the leading coefficient was just the 1. So then what it means is that the possible factors, or possible zeros, will just be this ones here. Because we're only dividing by 1. All right? Okay, so let's see this theorem in practice now. Do you guys need some time to copy those? Okay. For problem number 5, we're going to use the rational zero theorem. And for that, we need to get the factors of the constant term. So that will be the factors of -4. And then we're going to divide them by the factors of the leading coefficient, which happens to be a 1. So that will be an easy one, okay? So factors of 1. So what this tells me is that the factors of -4 are plus minus 1, plus minus 2, and plus minus 4. Yes, always plus minus, because we have to think about this. -4 could be divided by positive 1, but it could also be divided by -1. So yes, we will always consider both the positive and negative. And the factors of 1, that one's easy, it's just plus minus 1, right? So if we were to use that corollary of the rational zero theorem, the one that says that if the leading coefficient is 1, the factors are just this one up here. I mean, the possible, I'm sorry, let me rephrase myself. The possible rational zeros. Okay, so the possible rational zeros. And so those will be plus minus 1, plus minus 2, and plus minus 4. So how many possibilities do we have total? 6. Very good. Okay, so Isaac, Silva, make a guess. Which one would you like me to test with a 0? Any of these 6 numbers. So positive 1, negative 1, positive 2, negative 2, positive 4, negative 4. Which one?
Positive.
Positive 4, all right. So, since I'm going to check if it is in fact a 0, according to the remainder theorem, what should I get here?
0.
A 0, right? So let's see if this is true. So I'm going to take the coefficients. So I have 1x cubed, 2x squared, negative 2x, and negative 4 as a constant. So drop the first term. 4 times 1 is 4. 2 times 4 is 8. 4 times 8 is 16. Wait a second. I've been doing really bad math all day. 4 times 8 is 32. 32 minus 2 is 30. 4 times 30 is 120. 120 minus 4 is 116. So, will that be a 0? No. Yes. 136. Oh, this one. You know what? You guys are not gonna believe this, but I made the same mistake with my previous class. Is the coffee? This should be a 6. 4 times 6 is 24. 24 minus 2 is 22. 4 times 22 is 88. 88 minus 4 is 84. So it still doesn't work. So let's see, Jasmine, pick a number. Negative 2. Okay, so negative 2, coefficients 1, 2, negative 2, and negative 4. So we drop the first one. Negative 2 times 1 is negative 2. 2 minus 2 is 0. Negative 2 times 0 is 0. Negative 2 plus 0 is negative 2. Negative 2 times negative 2 is positive 4. Negative 4 and 4 is 0. Nice guess. Nice guess. That's what we call a lucky guess.
GG, good guess.
A what?
GG, good guess.
Good guess? Okay. Did I do my math right? Let's just double check.
Yes.
Yes. Okay. Now, let's retrace our steps. So, what was the degree of the original polynomial? The highest exponent is?
3.
So, we started here with x cubed. This was the x squared. This was the x. And this, the negative 4 is just a constant term, right? So, since we divided by something of degree 1, the resulting coefficients will represent x squared. That will be 0 what?
X.
0x. And the negative 2 is a what? A constant. There you go. So let's see what we have so far. Thanks to Jasmine's lucky guess. So let's see. We have found one of the zeros. And that was x equals what? Negative 2? Okay. So if we know what the 0 is, could we know what the factor is? Yes. If we just take this negative 2 across. So what will the factor be? X plus 2 or x minus 2? X plus 2. Very nice. Now, based on the synthetic division that we perform, we could say that this one is another factor. And so that factor will be x squared minus 2. Right? Because we already agreed that there was no x, 0x. So now, can we go from a factor to a 0? Yes, how then? Equal that to what? To 0, and then solve for it. So x squared equals positive 2, and then how do we undo a square? Square root. So that tells me that x could be the positive square root of 2, or what else? The negative square root of 2, right? Remember, here the answer will be x equals plus minus the square root of 2. So, and actually, we could also say that irrational zeros, such as the square root of 2, will also come in pairs, just like imaginary ones. What is the degree of the original polynomial, guys? 3. How many zeros do we have? 3. So does that make sense? Oh, Alexis, you gotta take more notes. Come on. So does it make sense that we have 3 zeros? Yes, yes it does. Okay. Now, I want to give you guys a problem where you have to use a rational zero theorem, and it just happens that all the remaining problems you can't use it. We tried earlier and you can't. So let me ask you guys to do one thing for me while I find a good problem. You're going to solve example 6. But I want you to just solve it by factoring. Okay? I'm going to look in the pre-calc book and get a good problem for you to practice. So this one, try to factor it this way. You can work with a partner or work by yourself, that's fine. Okay, so let's finish this problem quickly because I want to show you some examples of the rational zero theorem. So in this case, we take the square root, and of course, we're going to get plus minus. What is the square root of negative 1, guys?
1.
I. So remember, here you have x equals positive I and x equals negative I. Now here, same thing, take the square root, so x will equal plus minus the square root of negative 1 times 7, so that will be plus minus I, and then the square root of 7 stays inside. So that means that you have the positive I square root of 7 and the negative I square root of 7. Now, quickly before I move on, I'm going to write down the factorization of this problem because it's a difference of cubes and we're not very familiar with them. However, they're still very important. It's very important that we learn how to factor them. so in this case, we will get x minus 1. Why? Because you take the cube root of each term. Then the next factor is going to be a trinomial, where we take this term and we square it. So what is x squared? Just x squared. Then we take this term and we square it. What is negative 1 squared? Just positive 1, right? And then the term here in the middle will be, if we start with a difference of cubes, then we should have a positive sign, and it will be the product of x times 1. So that would just be x. So those are our factors so far, x minus 1, x squared plus x plus 1 equals 0. And so what I'm going to do here is I'm going to have to use quadratic formula, but because I cannot factor it. But I just want to skip that one there, because the ones that I'm going to use next, I'm going to use quadratic again, and so I want to be doing the same thing over and over, okay? So for now, for this lesson, we're done with this handout, okay? So you will need maybe an extra sheet of paper, or if you want to use the space that you have left here.
Can you scroll up so I can? No, up. Yeah.
That one?
That's good.
Okay, so go ahead and get some paper ready. And we're going to do about 3 problems. Okay? Now, these 3 problems, you will have to write them on some scratch paper or notebook paper. You could just add them to your notes. And so the first polynomial I want to work with will be that one. And remember, we are using the rational zero theorem. And so that one states that we need the factors of the coefficient, and we're going to divide them by the factors of the leading coefficient, which is 1. Factors of 6 will be plus minus 1, plus minus 2, plus minus 3, plus minus 6. Factors of 1 are just plus minus 1. So what this tells me is that by the rational zero theorem, the possible rational zeros will just be the numbers that we have here divided by 1. So positive and negative 1, positive negative 2, positive negative 3, and positive negative 6. Okay? All right, so Angel, take a guess. Let's see if you can give me a good guess.
8.
No. From positive and negative 1, positive negative 2, positive negative 3, positive negative 6.
Wait, what?
So just pick one of these numbers, either 1 or negative 1, 2 or negative 2, 3 or negative 3, 6 and negative 6. Sometimes books will list them this way, okay, without the plus minus.
Negative 3.
Negative 3, all right, good choice, good choice. Okay, what are the coefficients that I need? 1, what else?
2, negative 5, negative 6.
All right, let's see.
Drop it down.
We drop the first term, then negative 3 times 1 is negative 3. 2 minus 3 is negative 1. Negative 1 times negative 3 is positive 3. Negative 5 plus 3 is negative 2. Negative 3 times negative 2 is positive 6. Negative 6 plus 6 is? 0. So yes, good job. So x equals negative 3. So if we know that that is the 0, what is the factor, guys?
X plus 3.
Plus 3. It's very important that you know how to go from one to the other, okay? Now, I have good news for you. Since we already found one of the zeros, we don't need to go back to the original coefficient. We can continue here.
Wait, what?
Yes, yes. Because it's like we're just factoring. Okay? So let's see, who would like to take another guess? Positive what? How do you know? Like seriously,
I'm guessing.
are you really guessing? Okay, yes, it's actually positive too. I know because I checked the book, but he's right. That doesn't happen too often.
Not the both are right.
All right, so let's see if Luis is right. Drop the first number. 2 times 1 is 2. Negative 1 plus 2 is 1. 2 times 1 is 2. 2 minus 2 is 0. Yes, you were right. So if the 0 is x equals 2, what is the factor? And do you guys notice that we can actually get our last factor from here? So we started, what was the degree of our polynomial? 3. This was x cubed. This was x squared. X, and then the constant. After we performed synthetic division once, this turned into 1x squared, negative 1x, and the number, the constant. So then the very last row of coefficients, the 1 represents what? X. Not the x squared, 1 degree less, so that will be x. 1x plus 1. So now we have a factor, right? The factor is x plus 1. Could you guys tell me the 0? Negative 1. Okay. Was that listed as one of our possibilities? Yeah. Negative 1, positive 2, negative 3. Yes. All right. Let's do another one.
No.
We're not going to ask Luis anymore. So the polynomial will be x cubed plus 7x squared plus 11x minus 3. And that is equal to 0. So now what we're going to do is, of course, list all the factors, right? And so we need the factors of the constant term first, negative 3. And we're going to divide them by the factors of the leading coefficient, which is 1. Factors of negative 3, those are easy, just plus minus 1, plus minus 3. And that divided by plus minus 1. So how many possibilities do we have, guys? Possible, rational, 0. So 4, right? Positive 1, negative 1, positive 3, and negative 3. Okay, now I want you guys to test them. So you're going to perform synthetic division. If your remainder is equal to 0, that means yes, it is a 0. And don't ask Luis. So the only real 0 was x minus 3. From there we get the factor x plus 3. And the other factor comes from here, from the resultant coefficient. That one cannot be factored any further, so we have to use quadratic formula. So I have my coefficients listed here, a, b, and c. So now I'm going to substitute, so it will be negative 4 plus minus the square root of negative, not negative, but positive 4 squared minus 4 times a times c. A is 1, and c is negative 1. You have to be very careful with those signs, guys. So negative 1, remember that, for c, for the constant term. And everything is multiplied by 2 times a, and a happens to be positive 1. So now let's simplify a little bit. Negative 4 plus minus square root. 4 squared, 16. Negative 4 times 1 is negative 4 times negative 1 is positive. What? 4. Everything over 2. So x will be -4 plus minus, what is 16 plus 4? 20. Everything divided by 2. Now what I'm going to do here is take two numbers, two factors of 20, where one of them is a perfect square, so those will be 4 times 5. And I want to do that because I would like to take the square root of 4 here. Square root of 4 is 2. And everything is divided by 2. Now, what this means is that the 2 actually divides the real part, but it also divides the imaginary part. And so right there, you can see here the 2's will cancel. And so here, what do we get if we divide -4 by 2? -2. And then here, we will have plus minus. 2 divided by 2 is 1, so we still say 1 square root of 5. So that means that our 3 zeros, we had 1 that was real and 2 imaginary. Oh, there was a negative in front of the 2, right? Negative, negative. Okay, so 3 zeros because we had something of degree 3. Okay, now we're going to do one more. And the polynomial, it is x to the power 4 minus 6x squared minus 8x plus 24 is equal to 0. Now, you guys might be thinking already that this 24, we need to get the factors of 24. And 24 just happens to have so many factors. Can you guys start thinking about all of those numbers? What about 4? What else?
8.
12. What else? That's right, right? 24?
Yes.
Okay, so how many combinations? I mean, how many possibilities? 1, 2, 3, 4, 5, 6, 7, 8 times 2, so 16. That'll take us a while, right? Okay, now I'm going to show you a little trick, which is not cheating. It's making educated guesses. However, you cannot use this on TSI, okay? So don't get too comfortable with it. Because you cannot use a graphing calculator. Okay. Who can read the polynomial for me, please? So, what's going on? Okay. X to the fourth power.
Minus 6. X to the second power.
Minus 6.
Yes.
X to the second.
Yeah. Minus 8x plus 24.
Hey, what happened? Minus 8x.
Plus 24.
Oh. What do you guys see? Where is it touching the x-axis? 2. At 2. But you guys see how it's touching and turning around? Turn around. So it could have even multiplicity. Let's see if it's true. Quickly, quickly, because we want to go, right? Who wants to go home? Not you?
Yeah, more homework.
Okay, what was that number, guys? Because I forgot. Was it 2? Okay, so coefficients are 1, -6. Am I making a mistake? Someone catch me, please. Did I make a mistake?
4. There you did.
Are you sure?
There's a 0.
Do I have an x cubed? No. Need a 0. -6, -8, and 24. So let's check. 1, 2 times 1, 2. 0 plus 2, 2. 2 times 2, 4. -6 plus 4, -2. 2 times negative 2, negative 4. 8 minus 4, negative 12. 2 times negative 12, negative 24. And we get 0 for the remainder. So what does that mean? That means that we got one of them. So what does that mean in terms of factors? What's my factor?
X minus 2.
X minus 2. Now, we said that it was repeating, right? Let's see if it's true. So I'm going to do synthetic division again. Drop the first term. Multiply. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 2 plus 8 is 6. 2 times 6 is positive 12. Negative 12 plus 12 is 0. So yes, we have it again. What can you guys tell me about the other two?
They're imaginary.
They're imaginary. So we'll stop here for today. We'll find the imaginary ones next class. Hold on a second. Jasmine was telling me something that is very true. If I want to write these two together, it will be x minus 2 squared. So that's another way you could check that it is double or even multiplicity. Okay, guys, so go have fun.